Hi, IB. So 9b is our second rule for chapter 9, which is the cosine rule, also known as the law of cosines. And we are particularly going to be thinking about how do we find unknown sides or angles if it's not a right triangle. So cosine rule is going to help us, but only in these two cases. Either we have to be given all three sides, and therefore we can find one of the angles, let's say that one, or we could be given the angle that's included between two given sides. And then we could find maybe, let's say, the opposite side. Okay, but those are the two different scenarios that we pretty much use the cosine rule for. And we have to be given an oblique triangle, which is a non-right triangle, because if it was a right triangle, we would already know what to do. So we're looking at a case where how can we start to use our sine, cosine, and tangent with triangles, but in a little different way. So to start off, we start with a very familiar triangle to us, which is just a generic oblique triangle. This one's an acute triangle with corners or vertices A, B, C, and then our side lengths are little a, little b, and little c. And we start with something we know in order to prove something that we don't know yet, right? So we have Pythagoras, which we are very familiar with, the Pythagorean theorem. And in order to use Pythagorean theorem, we're going to have to split this triangle into two right triangles. So what I'm going to do here is just say that this is the height of our triangle, and therefore I've split this bottom side into two. So if we call this length x now, then I could say this side is a minus x. Since this is a law of cosines, let's think about how cosine would play. So for example, if I were talking about this corner right here, cosine of big C, adjacent would be x over hypotenuse, which is b. So therefore, x would equal little b times cosine of c. And I'm just setting this idea up, and I'm going to come back later in just a moment and use it. So just starting with Pythagoras, if I just concentrate on this triangle, that's on the left-hand side, the first one that I split my larger triangle into, I can set up c squared as my hypotenuse equals a minus x is one of my legs squared plus the height squared. I can expand. So a minus x squared expanded winds up being a squared minus 2ax plus x squared, and then I have this plus h squared. Now, if you notice in the right triangle there, x squared plus h squared can be replaced with b squared, because if I look on this right triangle, I can say, well, this leg, x squared, plus this other leg, h squared, is equal to my hypotenuse, b squared. So by using substitution, I can replace x squared plus h squared with b squared. Now earlier, we've already noted that x is little b times cosine of c. So if I replace x with little b cosine c, I wind up with a squared plus b squared, which is these two sides of the triangle. So here's little a and little b, minus 2 times each of them again, a and b, and then multiplied by cosine of c, which is the included angle. So this is the side angle side scenario. So if I have little a, little b, which are the two sides of the two legs of the triangle that happen to make up this included angle c, I can then find little c, which is the opposite side. So if I have the two sides with the included angle, I can find the opposite side length. If I happen to rearrange my triangle or just look at it from a different corner or different perspective, I could also find little a if I knew little b and little c. So little a would then correspond with large A as the angle, or I could also manipulate it so that I can find little b as the opposite side, and then big B would be my angle. So just in general terms, you're basically looking for an opposite side to the angle. So this would be my opposite side here. This is my angle that I'm trying to find, and I have adjacent number 1, and I have adjacent number 2, and that way I can find whatever piece of that is missing. So let's say I was trying to look for the opposite side. I would need this included angle and then the two adjacent sides. Or let's say I had all three sides, but I wanted to find the angle. Well, then this would be my adjacent number 1, adjacent number 2. This would be my opposite, so I could fill in opposite, adjacent, 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 and then I'd be trying to find the included angle. So it just depends on which piece of this equation you're actually looking for. If you happen to try to use the law of cosines on a 90-degree triangle, so on a right triangle, just think about what might happen here. Cosine 90 degrees is equal to 0. So if cosine 90 degrees equals 0, then this entire piece of the formula would wind up being 0. So I would just wind up with opposite equals adjacent number 1 squared plus adjacent number 2 squared, which winds up just being Pythagoras. So looking at an example of how this might work, I'm given little a, little b, little c, and I'm told to solve the triangle, which really just means find all missing parts that I don't already know. So if this were my triangle, and I call this corner big A, big B, big C, this would be little a, little b, and little c. So A is 18, B is 10, and C is 13. So this is a side, side, side scenario. Since I know all three sides, it really doesn't matter how I set up my little ABC order, but I am going to go ahead and replace my small a with 18. So 18 squared, following my formula, equals little b, which is 10 squared. Little c is 13 squared, minus 2 multiplied by little b, which is 10, little c, which is 13, and then multiplied by cosine of big A. So A is the unknown here. I don't know what this angle is. So at this point, I'll just go ahead and simplify as much as I can. So 324 equals 100 plus 169 minus 260 times cosine of A. So therefore, if we subtract 100 and 169, we'll get 55 equals negative 260 cosine A. Therefore, cosine of A is negative 55 divided by 260. So now we can use inverse cosine to find our angle. So by finding that angle A is 102, it also helps you reflect on your diagram. We can make this a little bit more of a realistic picture here. If I know that my angle A is going to be 102 degrees, that means it should be opposite the longest side, which is 18. And then we can make the B and C more appropriately drawn there. And then this is 13, and this one is 10. So that gives us angle A, and then once we have angle A, we can follow the same similar steps to find either B or C, angle B and angle C. And then once we have one other angle, then we're able to subtract from 180 and we can find our last one. So let's try to set this up one more time to find, let's try to find little big, what did we just find? Angle A, let's try to find angle C. Go ahead and pause here and set it up and then check and see how you do. All right, so since I wanted to find big C, I had to make sure that the little c was isolated and the large c was part of the cosine. So make sure those match when you guys set up your formulas. And we wind up finding that big C is 44.9. So now we can take 180 minus 44.9 and minus 102. And we can get our last angle, which is large B, 32.9 degrees. All right, so just making sure that we're choosing the correct way to set up, really. You guys are given your formula, so we're not memorizing this formula, but understanding where it comes from and then how the smaller lowercase letters correlate to the sides and then are larger. There's only one angle in this